Energy. Energy. When you play for a long time, you feel tired. It means your ability of playing is reduced. Why is your ability reduced? This is because you have done some work in playing and you have used your energy to do that work. So, energy is the ability to do work. 1. Energy is defined as capacity to do work. Let us take one example to understand it more clearly. To cut a log of wood, we have to raise the axe vertically upward, and some work has to be done in raising the axe. If the axe is now allowed to fall on wood, it can do work in cutting the wood. Thus, the work done in raising the axe has been stored up in it, giving it the ability for doing work. 2. Energy can be measured in terms of work done. The amount of energy possessed by a body is equal to the amount of work it can do when its energy is released. Unit of energy. Energy and work are directly related to each other and are mutually convertible. So, the units of work and energy are the same. The SI unit of energy is joule, J. The energy required to do 1 joule of work is called 1 joule energy. Bigger unit of energy. Sometimes, bigger unit of energy is used, which is kilojoule. The symbol is kJ. Now, 1 kilojoule is equal to 1000 joules. Energy can also be measured in calories. 1 calorie is the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. 1 calorie is approximately equal to 4.2 joules. 1 calorie is equal to 4.2 joules. Do you know? A 60-watt light bulb uses 60 joules of electrical energy every second. Different forms of energy. There are different forms of energy. Mechanical energy. Energy by virtue of which some mechanical work is done is called mechanical energy. It has two forms. 1. Kinetic energy. 2. Potential energy. 1. Kinetic energy. The energy possessed by a body due to its motion is called kinetic energy. A moving car, an arrow shot from a bow, a player throwing a ball, all these are the examples of kinetic energy. The water flowing in a river and a high-speed bullet possess kinetic energy. A swinging pendulum also possesses kinetic energy. The kinetic energy of a body depends on the following. 1. Mass of the body. 2. Speed with which the body moves. Its formula can be given as kinetic energy is equal to 1 by 2 mv square. M is equal to mass of the object. V is equal to velocity of the object. Ke is equal to kinetic energy. If the mass of a body is more, it will have more kinetic energy. For example, if a car and a scooter move with the same speed, car will possess greater kinetic energy because of its heavy mass body. Similarly, greater the speed of a body, more will be its kinetic energy. If the speed of a body is doubled, its kinetic energy will increase by 2 into 2 or 4 times. If the speed of a body is halved, then its kinetic energy becomes 1/4. Activity. Take 1 lighter and 1 heavier hammers. Strike both the hammers one by one on the iron nail fixed on a wooden board. What do you observe? The nail penetrates deeper into the board when the heavier hammer strikes the nail. So, we can conclude that the kinetic energy of moving heavier hammer is more than that of lighter hammer. So, the amount of kinetic energy depends on the mass of the moving object. Activity. Take a carom board and place a few carom coins on it. Hit these coins with the help of a plastic striker. The coins move to some distance due to the force applied by the striker. Now, push the striker again with a greater force. You will find that striker moves rapidly and hits the coin. As a result, the coins move at a greater distance. So, we can conclude that kinetic energy depends on the speed of an object. 2. Potential energy. The energy possessed by a body due to its position is called its potential energy. The energy stored in a body is also called its potential energy. Examples: 1. An object placed at a rooftop of a home possesses potential energy. 2. Water stored in overhead water tank possesses potential energy. Activity. Take a catapult. Put a stone in the rubber loop and stretch it. The moment you release it, the stone will shoot out with high speed. This shows that energy stored in the catapult is transferred to the stone and it moved very fast. Scientist. Sir Benjamin Thompson, Count Rumford, was an Anglo-American physicist and inventor whose challenges to establish physical theory were part of the 19th century revolution in thermodynamics. He also served as a colonel in the Loyalist forces in America during the American Revolutionary War. Rumford had observed the frictional heat generated by boring cannon at the arsenal in Munich. Rumford immersed a cannon barrel in water and arranged for a specially blunted boring tool. He showed that the water could be boiled within roughly 2.5 hours, and that the supply of frictional heat was seemingly exhaustible. Fact: up to 97% of the fuel nuclear reactor can be recycled into fresh fuel and reused. The potential energy of a body depends on the following: 1. Mass of the body. 2. Its height from the Earth's surface. 3. Acceleration due to gravity. Potential energy is equal to m into g into h. M is equal to mass, h is equal to height, g is equal to acceleration due to gravity. If a body is kept at a greater height, its potential energy will be more. If two bodies of different masses are kept at the same height, body with greater mass will have more potential energy.